All right, so this is what I'm going to tell you. It's practically about my own creation, which I am sharing with you almost privately now because it's a very fresh thing. But a little bit about myself, as Laura already presented, I just wanted to show you what it is in practice. That Europe launched in 2018 a very long-term in European Commission terms, a 10-year-long flagship about quantum technologies, which is to push quantum technologies from the laboratories to the market. And we have already heard a lot about quantum computing, and most of you already know about it. Also, there is an information technology and sensing technology, and a lot of exciting stuff. So this big flagship needs always a coordination action, and so on the left side is the flagship part, and one of the coordination subsection was dedicated to the education, actually, and training. And this is on the right side. And then there's quantum technology education, coordination action. And we set up a community which we call QTEdu. And a lot of people are working on producing so many great products, which we are putting all online on our website, QTEdu.eu, and you are very welcome to explore it and use it for whatever purpose, to clarify or to demystify some of your doubts. Okay, now I will not make you see the video because I have too little time, but there is a funny video on the website of the Quantum Flagship. Go and search it later. So about myself, you can learn also a little bit more on the website of the flagship. I also did various of those resources, and they are all in the page. So, for example, I hosted several of the game cafes where I brought a lot of games. I'm not a game creator, but I love people play games, and so I put those new fresh games in the cafeteria of a city, and then people come and play, and this is usually working smoothly, and everybody's happy. And but once I wanted to participate in an event in Trieste, which is a mini maker fair, where makers from the makers community and Fab Lab community present what they have. Well, I'm not a maker in the sense of a Fab Lab participation, but I like to disseminate and talk about science, as Laura mentioned. And so I thought, why wouldn't I create something where we get a full body experience? So this was my premise. Then it's going to be a real lab experiment inspired, let's put it this way, and as close to it we're gonna like live it through, but full body. And I wanted that we really dive into this realm of quantum probability, which I will try to repeat a little bit more, like what comes strange about probability, and even more that we didn't know about it when we talk about quantum objects. Okay, so it came out to become in the beginning a workshop, something like experience. So I still don't know how to call it, but with your help, maybe it will come out as a game. With some of your teams today. So practically, it's like acting experience. So people will just do what the usual quantum objects will, with a lot of imagination, of course, because it's not quite possible for us. And then it's a group activity where we need at least 4 participants. And then it's a collaborative one. If we want to add a game spirit to it, and let's see if it's possible or not. So the game was inspired by this experiment of the 1986, which was done in Paris by Philippe Grangier, Roger Aspect, and they practically had convinced everybody that single photon exists, so single light quanta exists, and they also demonstrate their peculiar behavior. And so the peculiarity of it is that if you like split your photon in on a beam splitter, it's called like, it's an object where you can go straight or turn and reflect from it. So it's the first beam splitter. So it splits into two paths, go down or go up, then reflects from the mirror, and then you recombine it again. So from both sides, it enters into a splitting mirror again. Like you could think maybe it comes out one way, one output, or it comes out to the other output, and practically a typically classically random object, random walk, let's say, if the object can go either down or up randomly, then it can go either down or up again, and it can come out of one or another output randomly. And it turns out that quantum objects like a photon don't do this. So it comes in from one input and it comes out from the one output all the time. Always the same. Peculiar, let's put it this way. So what I do, I say, okay, let's build the interferometer. It's called Mach-Zander interferometer because Mach and Zander has built it independently a long time ago. And then the interferometer, because you have two passes, and then there is a moment when something interferes, because when they recombine. Okay, we'll see what this thing is actually now. So what I do is, I will show you now the video. I set up like these two passes. So this is the entrance. You have to choose. You go straight or you go down. You reflect. So you hear Italian on the back because it was in Italy. So the first beam splitter, you're gonna choose to go straight or to go down. Then you reflect from the mirror. This is no choice. There's just action to do. And then there's a second splitter. You can go straight or you can go down. And you have to. So as simple as this. And then I let people go through it. Many people, when they think like they just choose what they do twice. And then at the end, we see that people are coming out on both sides. Okay. And this is typically classically expected behavior. But how do we mimic this quantum behavior, which is observed in the experiment? Okay. So to do this, we need to go. And how do I get out? Okay, so this was actually the setting, and I also did a little bit of quizzing before we started an experiment, and it was 2018 in Trieste in the Mini Maker Fair. So practically, to mimic somehow the quantum thing, I discovered that we need at least 4 people, okay, because they have to act as something which is a kind of a new concept that we had to introduce for quantum objects, which is not probability itself, but the probability amplitude. Okay, I make a pause here because I think it's very important. It's a probability amplitude. So it's an extra quality of a probability that is not probability itself. And it's a funny thing. It has to be squared, modulus squared, to become probability. Okay, so peculiar thing. I don't want to focus on this too much now, but the point is that we need 4 reference points to introduce this probability amplitude, because these are practically all possible outcomes that has to be considered at the same time for this one object, which is also strange because it will be kind of delocalized. So practically what I did, I prepared these 4 things, which are the transparent sheet, 2 transparent sheets, one over the other, and one can rotate. So the picture will rotate, and one will have to rotate every time you're turning in the game. Okay, so now we're gonna run it once. So 4 people start at the interferometer entrance. And then there is a splitter. Okay, so 2 will go down and 2 will go straight. Okay, those who go straight, they don't turn their devices and they are staying like they are. And those who go down, they turn and then down or up. depends how the beam splitter is oriented. So important is that they turn, and then their devices also turn 90 degrees. Okay, so now we have two passes. Then they both reflect from the mirror, so they turn again. Okay, and now from each pass, they have to split again. Okay, so one does not turn of the pass, and the other one turn again. Well, now we are already getting a bit confused, I'm sure. One has to pass it many, many times to get somehow familiar with it. And then, but it's easy to construct, so nothing complicated here from the point of view of a device of the tool. And then practically what happens is that at one output, which is now I colored them, you will have two of these tools, and at the other output, you will have two other tools, and one has to overlap them. So with the reference frame which is given. And what comes out is this. So on one output, there is a picture which symbolizes the photon here. And on the other output, you get into all black, which means nothing, but no photon. So practically with this simple tool, I managed to demonstrate that no matter that, the possibility for the photon is to pass everywhere and to do whatever it can do. But because of this, with the help of this amplitude, probability amplitude, we can actually predict the exact result, which is at the experiment level. So the photon always comes at the same output, and only at that output, and there is never random outcome of the result, which intuitively looks a little bit strange. Okay, so that's how the experiment works, and I was advised by some gamers who know how to do games that to make it a game, one could possibly say, okay, this is the output. You get to get out bright, like you get to get out with the photon just from there. And then people are getting their tools and they have to figure out how to do it by themselves. So I'm not telling them the rule. I'm not telling them you have to turn and you have to turn the photon when you turn. You don't have to turn when you turn. So they have to figure that out by themselves. So it's like an exploratory journey to arrive where they have to arrive. I think it's a cool way of trying, and next time when I will have an opportunity, I will try that. But for the moment, for the first time I did it, I only said, okay, these are the rules, try to follow them, and let's see what happens. This was already not easy, paradoxically, because it looks simple, but when people have to walk and turn and think how to combine the two, it comes into all types of errors. And this was also an occasion for me to say that there are also experimental errors with every experiment that is disturbing a lot and causing us troubles. So I had a lot of fun with it already, and if you wish to have fun with it as well, you're very welcome. And here I just put where I've been presenting it, and I will be doing it actually in a week here in Trieste again. And yeah, if any of you wishes to pick it up and develop something on it, or making some online something online similar with this inspiration, I'm welcome. I'm available, and I'm happy to be part of your creation. That's it. So here's my email address, and you can also search for me in the website of QTEdu, and I wish you a lot of fun.